Well, welcome everybody back. What do we got? Week two, day two. Just wanted to cover chart types today, just generically, um, graphs. And then I want to do Python notebook number 3, if then else logic, which can be tricky if you haven't worked with it in a while. And then of course, Python has its own syntactical weirdness that you gotta remember. Okay, so give me some idea here, guys. Let me share my screen. Stand by. Yeah. Zoom, back to Zoom. Come on. Give me some ideas. Seth, what is your go-to chart type or types?
Well, I haven't had to use any sort of chart types here. Like we haven't done any kind of visualization as far as the things that I've been asked to do in my position, right? It's mostly just getting raw numbers and giving them to somebody else.
Raw numbers in tabular format. And that, depending on how condensed and information packed that table is, like, do you mostly pivot tables or mostly raw data?
It's mostly raw data. Sometimes they'll want it in a specific format. I've used pivot tables too, but they'll say, hey, I want it to look like this or this or this, and then I'll have to go back and redo it basically and make it look like they want it to look.
Okay. Is it safe to assume that somebody is taking that data and turning it into some sort of chart or report? Or
If they are, I haven't seen it.
Well, all right. How about you, Edgar?
But we do.
That was a little crackly. Can you test your audio again?
Can you hear me?
It's a little faint, but yes. And then there'll be a pop every now and then.
So I haven't had to use chart types.
Okay.
Reports that have charts on them, but I don't necessarily.
Okay. Well, we'll cover these because you have to. Kevin, how about you? What are you seeing?
For my work, I mostly deal with like pie charts or like bar charts. Sometimes we'll stack the bars, for like easy summaries or breakdowns of the data, but um, that's basically it. We don't really work with any like scatter plots or line charts from what I've seen yet.
Okay. Or trending
Nothing
data,
super
nothing like
advanced.
that.
Yeah.
Okay. Well, we'll go over these, and then there are other more cosmic ones. These are like the absolute basics to get started, if with the most common data types. But there are some whiz bang visualizations out there, and then combining a visualization with the right text, so either summary data in a little table or a text box that this is important, and then the way you present that data verbally as you walk through the story of the data and point out what's important. These things are really useful. So I'm just going to go over the basic ones. I think most of these visualizations or most of these images are out of Excel, but not necessarily. But I just want to make sure that you're aware of them, because we will be working with them somewhat as we go through. Because I just never assume in this class that you'll always be doing what you're doing, and that it isn't interesting information for an analyst to have, because who knows what, what your duties might evolve to be. If you see something that's exciting and throw your hand in the air and say, I'd like to try that. Knowledge is power. So there you go. All right. So we'll get started here. Column chart usually has a category along the x-axis, and then the amount going up the y-axis. And these are really handy for clustering data. Like if you have, like we've got dolphins and whales, so we've got two columns, two series, they'll call it in Excel, that you are comparing year to year to year to year to year to year, and Excel will sort that x-axis. So it if you do the data correctly, it kind of auto sorts and starts to look like you'd expect. But yeah, column chart lets you compare between categories, so that that 2017 and 2018, that could be different oceans of the world. So our observations here is the number of the wildlife population. So we've got numbers of dolphins and whales, but those bottom category, those are really categories that clusters the subcategory within. So you've got blue for dolphins and orange for whales, but within different categories. So those could have been the different oceans of the world. That could have been dolphins and whales in the Pacific, Atlantic, Indian Ocean, instead of by year. Year makes some sense. So you can start to see trending with a bar chart. You can see just the relative heights, and a column chart. And a bar chart is just a column chart laid on its side. So I'll talk about these kind of in the same breath. One thing, and I don't have an example of it here, but we'll be able to look at it, is stacked. Like for this one, be a stacked column chart. And what that would do is it would take this orange bar for whales and it would stick it up on top of the blue bar for dolphins, and it would show the total of all animals for that year. But then the if you stack it, it shows and there's two colors. It shows you the relative contribution of each of those two within that one category. In this case, would be the year. So this comes in really handy if you've got 6, 8 different subcategories. Like what if we had dolphins and whales and tuna and swordfish and seals and different 6, 8, 10 different subcategories. You do a stacked bar chart or a stacked column chart for each year going along, or each business location, subunit, whatever, and it kind of starts to show the relative. Each color will have a like a almost like a, I don't know what you'd call that, a speedometer, the relative contribution to the whole, like a pie chart, almost like you'd have individual pie charts, but it's easier to read. Okay, so that's column and bar chart. And there are, when you are in Excel or Power BI or even Python, you tell it these different subtypes, and the magic happens, and it automatically puts them out there. 3D is kind of gimmicky. I don't know. It depends on your work and your customer, whether or not they like to see things in 3D. It can look kind of cosmic, kind of cool. And there are some visualizations that benefit from it because that third dimension actually tells you something. but they can look kind of gimmicky. We'll go through that in not next week, but the week after. We got two basically full class sessions on Excel, on pivot tables and formatting and VLOOKUP and functions and all that stuff, and some charting. Okay. And a line chart is what you would use to show continuous data, generally over time. It's got to have some sort of order to it along the x-axis for it to make sense. It's really good for showing like a like a stock chart, stock market chart, daily or weekly changes in stock price. And really handy, you can have multiple many data series, which is what you would call each variable here, each category, each column: bears, dolphins, whales. And you can start to see where they the effect that they have on each other. And I don't have a copy of it, but there's when we were in Alaska, we learned of a natural cycle, and it's called like the hare fox hare cycle. And there's like 3 interdependent species, like the plant that the rabbits eat, and then so if you have a really good wet, warm, whatever, you have a boom in that plant, you'll have a lagging boom in rabbits because they eat the plants, and then you have a lagging boom in the fox population, but then they overfeed, and when the plant goes back down, you start to see the reverse cycle happen where times get short. But you can start to see how different variables have a cyclicality or kind of a cause and effect that pops out when you look at it that you would never see from just a CSV. So yeah, that's a lined chart, and there's line chart, and there's subtypes, of course. And then the much maligned pie chart. I don't know if you guys ever heard people dogging on pie charts? Okay, I'll take that for a no. I don't know. I did Excel and the appropriate chart for that data type as a full-time job, I don't know, maybe 10, 15 years ago. And the pie chart gets a lot of grief. I think it's mainly because it gets overused sometimes, and particularly if there are too many wedges. If you've got more than a half dozen or so wedges, I'm sure you've seen a pie chart with 70 wedges, and it's just ridiculous. But especially if it's if it's not something you were expecting proportion, this just visually just makes it jump out at you. The proportion, that's what a pie chart is really good for, is what is an individual variables or column attribute, what is its contribution to the whole in relative. So the pie is the whole pie, right? That's the all wildlife that were observed, and then you break each slice down into its or the software breaks each slice down into its relative contribution. So with really quickly, it's easy to see dolphins outnumber bears, what, 100 to 1 or whatever. Yeah, that gives you some indication. But generally speaking, for something like this, a table next to it, a value table, which you can do in Excel, will kind of help. Okay, no kidding, there's a lot more orange than blue, but how many? And you get to see the actual values out next to the pie chart. That can help. And then, like I said, there's a 3D pie, but it's just kind of, eye candy. I don't know. It all depends on what your data customer consumer wants to see. Hey, good morning, Cameron.
Hey, morning, sir.
Good to see you.
Yep, you too, man.
Okay.
Just got through watching the last video. So
Okay. Well, I'm glad you're here. Are you going to be able to stick around for a little while or?
yeah, I'm here.
Okay. We're doing Python if then else logic and how that works. And then we'll have, I'm going to cut you loose here. I guess the majority of the day to do an assignment or exercise. I got 5 programming from easy to thought provoking on if then
Okay.
else. Okay, so yeah, pie chart. Like I said, if you're doing reporting like this and you're a business intelligence analyst or whatever, and you're doing dashboards, they'll let you know if they don't want a pie chart. You generally speaking, you'll know. An area chart is similar, but it's showing you at any one point in time, like January, February, what the contribution is by filling in the color. So it kind of does trend analysis like a line chart, but then it can kind of show you proportionality, kind of like a pie chart. The weakness would be when there's overlap. Sometimes these things are really interesting when the variable in the front, shows an area, and then the variable behind it is just a little bit more, so that it kind of peaks up behind and then behind. So if the layering of the data makes sense, these can be useful, but it can also hide data. So you just got to really be careful. And again, as an analyst, you have to analyze its utility. Okay, so that's our area chart. Now, a histogram, I've seen some confusion if you don't work with charting very often. A histogram looks exactly like a column chart, or looks very similar to a column chart, particularly a column chart of one variable. But where a column chart is kind of looking across categories, like I said, these are years, but they could have been the different oceans of the world or whatever. A histogram looks at a single continuous variable and counts the number of occurrences within that category and shows that number of occurrences on the y-axis. So, for example, so it's showing you the distribution of the data to see if it's like really skewed one direction or the other, which can be a significant finding of the data, or a significant factor that you might need to know about. Or like I was saying, I don't know, last week or earlier this week, like I was saying previously, most natural phenomenon, like people's heights and heights of trees, or the number of trees per acre in a forest, or that kind, anything like that, tends to be a normal bell curve, like we're all used to. And this one, for example, we've got, and you can see that there are, by the scale, there are 3 people in the 3 employees, male employees, that are 5'7", and 6 that are 5'8", and so on. And like I said, it gives you an idea of the distribution of the data. And you can, in any software, Excel, Python, you can set the size of the bins. So when you set the size or number of bins, either way, it same ratio, you start to see more kind of, whatever you call it, fidelity, more accuracy. as to the distribution of the data. Okay, histogram. So that's like the first thing that you do when you've got a single continuous variable is throw up a histogram and check out the the distribution of the data. And of course that will, if you had, you know, a 7-footer, it would make your histogram, you know, have the normal, and then you'd have that one outlier way out there on the right. And that's why, you know, median or mode can be more meaningful than a straight mean or average. If you've got an outlier, just like we saw in that Anscombe's quartet, that one outlier can blow away all of your descriptive statistics. And it could be bad data, it could be wrong, but it could be something worth investigating, something really good. Like you might have one salesman that sold 5 times more or whatever than someone else. Outliers are not, you know, something that you discount automatically. It could be something. It's worth investigation, regardless, because it could be dirty data, but it could be something worth investigating. Customer fraud data will stick out sometimes. Number of transactions. Certainly, cybersecurity data. When something sticks out, it's worthy of investigation, because it could be a bot or a malicious malware that's pinging on a port. Okay, histogram. That's how you look at your continuous a single continuous variable. And very similar to a histogram is a box and whisker. But like I was saying in the previous session, you can put box and whiskers for multiple variables close to each other and get an idea of, you know, where the median is versus the min and the max, how spread out the data is. Easier than you can individual histograms. So they're handy. And guys, I am not even the only source of information on this stuff. So all of this is Googleable, as anything else is. If you're interested in it, if I'm unclear, hit the books, and if you find something interesting or a good tutorial or example or whatever, please let me know. So a box and whisker does the same thing as a histogram, but it's a little more accurate, a little more precise in the way it reflects the data. The middle line in that box is the median, the centermost value in that list of values. And then it goes, so if you had 100 observations, that's your 101 maybe. It'd be your 51st observation. And then Q1 is the 25th quartile, or the first quartile, first quarter of the data. And the way that box stretches on one side or the other of the median shows you if you have really nice symmetric data or if it is skewed. So you've got the box, and then the whisker continues that and goes all the way to your absolute minimum observation and your maximum observation. And then you will see box plots like the most box plot is more what I see more often than box and whisker. The whiskers are the little things that go out to the min and the max outside of the box. You will see frequently like at where the max is, it won't just be a line and a single dot. You'll start to see dot, 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 and it kind of figures whether those are outliers that towards the min or the max that factor in, and it just brings those to your attention. So yeah, these have all been box and whisker histogram are single variable to look at the distribution of a single continuous variable. And then for two continuous variables, like we said before, we got the scatter plot, and you can click on it and get it. Generally, Excel or Python or whatever, they will default to drawing the scatter plot without the line of best fit that shows you, no kidding, what the relationship is, and it won't show you the equation of that line, which you can use to do kind of like linear regression and projection. But you just, yeah, like in Excel, you just right click on it. It's a parameter in Python. You just right click on it, say add trend line or add line of best fit, add equation. And it gets it on to the chart for you. But yeah, scatter plot is really good to show two continuous variables and how they relate to each other. One limitation or something to be aware of is the scale. If the two variables, like one is in, you know, millions of dollars and the other one is, you know, from a continuous variable from, say, you know, 3 to 25.4 or whatever, you're comparing millions to single digit integers or double digit integers, and it blows the scale of the line chart. And Excel will try and compensate for that, but generally what you want to do is get the numbers closer to each other by doing something like you know, in millions. You'll see, like, you know, budgetary figures on like, I was on the Wall Street Journal yesterday looking at Wall Street and JB Hunt's stock performance and net income and all of that stuff, and they report income in millions, so that you're not looking at you know, a ton of numbers. 8,000 million, otherwise known as 8 billion, I think. Anyway, yeah, scatter plot. So we'll have some exercises like in week 5, and then we'll roll into SQL in week 6. That should do us. And we'll do some exercises with these. But in the interim, if you're curious and you knock out your Python programs real quickly, you'll see in the classroom, go ahead and screen sharing in the classroom under, that's not the classroom. There's the classroom. Under Excel, where'd it go? Got to go blast past it. Excel, here we go. I've included a PDF copy. Hang on a sec. Looking at my camera of this giant book, and that is my human hand to give you an idea. And this doesn't even cover everything. It's the Excel 2019 Bible. That's what I use for looking it up and learning, you know, what all this stuff for Excel. And I found the PDF version on an academia.edu. I just, you know, you're welcome to use it. But just don't email it around to all your friends or post it online is all I would ask. And it's got a section on everything. It's got a great chapter, at least one chapter on charting. If you want to check those out. And then I went ahead and downloaded from the companion website of the book. I went ahead and downloaded sample worksheets and in a zip folder. And there is I want to say it's called charting. There's a worksheet in there that shows you these sample charts, and there's a tab for every Excel chart type. Some of them can be easier to use than others. The one that's the most cantankerous to me is a map. That's something that only came out in the last I don't know, 5-6 years. I think Excel 2016 maybe was the first time it integrated with Bing Maps in Excel. But if you've got state level data or even county level data, and the mapping software can figure it out and it's labeled right, like I said, it's cantankerous. It's not the easiest graph to work with. If you guys are working with like I don't know, like Seth, stores per county, in a given state or whatever, and then you want to look at sales geographically, like a darker color of the county means there was more sales or whatever the case may be. I had one student worked in healthcare analytics, and county level demographic data was very important to them. Anyway, all of these Excel chart types, which Excel doesn't have every one built in, but it's got more than what I covered, and those are the sample worksheets that are referred to in that Excel Bible PDF for you guys to use. I'll occasionally refer to it in the course, but that's there for your use. Just please don't email it around. Hi, Chris. We just went over chart types. It's the chart types PowerPoint in there. Do you do charting? You would be the only one if you do.
Yes, sir. And also mainly the maps you mentioned, like a lot of the county level, state level demographics, looking at things on like an actual map is very important to us as well.
Cool. There you go. Yeah, you can do those in Excel and Power BI. We'll try and link up a project. And if you have national level data, that it knows it adapts to the data. Now, I don't know that it does provincial level data outside. It probably does Canada, okay, like it does US states, but I don't know that it does provincial level data everywhere in the world. But it's pretty handy. Most of the really gee whiz, like I said, the gee whiz visualizations I see are web based, and it's one JavaScript library or the other that makes them really cosmic. But yeah, so yeah, chart types, just I've got to cover that. Even if you're not currently doing much charting, had to cover those types. So Chris, it's probably stuff you've seen, I'm sure, before. So you can just watch the video from the start or look at that PowerPoint. I was just giving my thoughts on the utility, when to use those basic chart types. So let's go ahead and take 10. We'll come back and do notebook number 3, decisions and Boolean logic. And then we'll do Python exercise. I'll cut you loose, and you can work on Python exercises 1. There's 5 from super easy to somewhat challenging. If then else. There's no looping or anything weird like that in this first exercise. So I'm going to cover if then else, and then you'll get some hands-on with it. And I'll see you back here at, let's do 9:15. Break until 9:15. Any questions real quick? You would have interrupted me, right?
I have one, Don.
Go ahead, Cam.
The pre-recorded sessions, are they on like in a tab somewhere in course or inside of a Canvas, or is there a special link we need to access those? Like
Oh yeah, let me show you real quick. We're in the classroom right now, right? Yeah. Am I still screen sharing? Yes. Okay, so if you go to basically your home page.
It's still on your PowerPoint.
I am still on the PowerPoint. Oh, yeah, you're right. Yeah, I wasn't sharing the whole screen. Thank you. Stop sharing that and start sharing screen. Okay, can y'all see the Canvas
Yes, sir.
modules now? Yeah, each one of these are just a link to the session recording for that date. And I upload them to YouTube. I've got a YouTube channel chock full of really boring content because I teach a couple college classes as well. But I load these up to YouTube and then I just post a link to YouTube in the classroom. So under this top module that says session recordings, usually within a couple hours, takes a little while to convert the video. And then of course YouTube has to do its magic with it. So it usually takes me a few hours. And if I don't get distracted, I'll post them there. Can you see those, Cameron, in Canvas?
Yep, yes, sir. Like on my Canvas page, it's a lot of like assignments from like November and stuff like that. I don't know how they got on there.
Well, if you click on assignments, yeah, what I did was I copied the previous course. So if you just click on assignments, it's probably going to look goofy. So
Yeah.
I would recommend you click on the modules. Where does it say modules? There it is, modules. And I think that's your default landing page when you first come in. I'll go into student view here. That's my view. So I'm going to see a whole bunch of garbage you don't see. Yeah, this is normally
Okay.
where you land. So yeah, if you click on assignments, in fact, in your view, let me do that. Yeah, that just shows you all the assignments that you will do, but the due dates are screwed up because I
Okay.
haven't
I see
adjusted
now.
them yet. Yeah, we were here last December, man. Where were you?
I don't know.
Yeah, that's just me. So like, what have we done so far? We did business problems, right? So May 13th. That one's accurate because that's the only one we've done. I'll reset the Python exercises, Python problems 1. I'll reset that due date because that's old.
Okay.
It's still active. I think you can still get to it. But the due date's messed up. And it's also gettable from I post a link to the assignment in the modules just to double down. And that is right here under Python. We're going to go over notebook number 3. And then this here is your exercise. And like I said, yeah, I'll adjust that due date. Python exercises 1. So the assignment is actually this notebook, which is just 5 markdown cells with the instructions of what to do with a code cell underneath it. And I have sufficiently yammered so that we need to come back let's come back at 9:20. 9:20. All right, we'll get started with control logic, conditional logic, branching logic, if then else in Python. So if you haven't done any logic coding, whatnot in a while, this can be a whole lot of fun. So I'm pulling up notebook number 3. Everybody seeing that okay?
Yep.
Okay.
Hey,
All right.
where are the notebooks located?
Let me go over there in the classroom. Go back to modules. And then down here, I've got each one of these chunks here, like session recordings and foundations. Each one of those is for Canvas, that's a module. So you can group stuff together, you know, by topic. So this little down arrow thing will shrink that up like you're used to. Foundations is where that chart types thing from today was. And I got one for Excel, and I got one for SQL. I still got to create the one for, oh no, I just got to upload content to data visualization Power BI. But then down here we got, oh, I don't like that if it's blank. Okay. Down here at the bottom module, we have Python programming. So that's all of the notebooks that I've used so far, along with a cheat sheet that'll show you how to format those markdown cells I've been showing you. There's Python number 2, and today we're doing decision and Boolean logic. So if you download those, I would put them in a Python directory, and underneath Python, I'd create one called notebooks, and put the notebook, the IPYNB file there.
Okay, got it.
Got it. And then,
Yeah.
Have you been able to download and install Anaconda?
Anaconda, yeah.
Okay. So all you do is define that notebook. You good now, or do you mean?
Oh yeah, I'm straight. Yeah,
Okay,
I'm good. I just need to know where they were.
Okay.
Yeah,
All
I'm
right.
good.
Well, all right. So yeah, number 3. So I'm going to go back and make sure I've covered the computer science part of it. If you haven't heard it in a while, or they never quite put it this way in your previous education, I'll make sure I cover it. So what these are for is to control what lines of code are executed and which ones aren't, because you don't always want to do straight line code. Sometimes you got to make a decision and do something based on a condition. And that's what we're doing here. It's classic if then else. Every computer programming language has this structure. Even assembly language has a compare and switch format, methodology, syntax. So we're going to go over the way Python treats these things, and you'll see, a Boolean expression. Something is either true or false. There's no gray area. There's nothing in between. Every operator and combination of operators and statements, and no matter how complex it is, it will either be true or false to the computer. So we'll go through those. So Python's relational operators are the usual less than, greater than, or equal to, which is kind of a compound condition in and of itself, which can trip you up. It's easy to put a less than into a test, a logic test, when you really meant less than or equal to. And then it's easy to forget that when you're comparing values to see if A equals B, you use 2 equal signs. And in Python, I will frequently call the exclamation point, I'll call that bang. Is that still used, the bang equals? Does that make sense, or is that what do you guys call the exclamation point?
Bang.
Bang. All right, there you go. I'm still hip. Bang equals, not equals. Some other languages I've seen the less than and then greater sign together, and that is not equal, but not in Python. Okay, so here is these expressions A greater than B, is A greater than B, is it less, is A less than or equal to B? Is A equal to, exactly equal to B, not equal? And then you can do a complex expression like this: 3A greater than or equal to 27.5 plus 2 times B. And this is generic, So those will either resolve to true or false. So down here, these are now code cells. And you can, I think I did this before, printing the expression 1 is less than or equal to 1 will print the resolution of that. It doesn't print literally the characters 1 is less than or equal to 1, since they're not in quotes. It's not a string literal. It's actually an arithmetic operation using the numeric literals 1, and then it puts the operators in purple so it sticks out for you. So we print that one, and we all know 1 is less than or equal to 1. It's actually equal to it. So we'll see that in the next one. So I hit Control, press Enter. True. Is 1 less than 1? No, 1's not less than 1, so we get a false. Is 1 equal to 1? Yes, generally. I think there are some people that could show you that is not true, but they're complete math nerds. Okay, is 1 not equal to 1? Print 1 is not equal to 1. And that is false because 1 is equal to 1. So they're testing the relationship between things. They're not making an assignment. So 1 equals 1 is not setting, or A equals B. It's not making an assignment of B to A, B to A, when you use the 2 equal signs. It's making a comparison. So the first thing to figure out when you're using these structures is the choices your decision structure includes. And I'll let you guys read. Again, this is from a relatively entry-level computer science course, and my buddy Mike's got a good sense of humor, so he's got a couple of you want to do this or that, you want to do this and that or that. There's multiple so many combinations, permutations of logic, but there are basically 3 main approaches. And the first one I'll cover here is when you've got 2 choices. So you're going to do something, otherwise, if that's not true, you're going to do something else every time. So it's two things, an if else. So the format in Python, it's important to note, particularly if you've learned programming in another language. It's pretty English looking, straightforward and readable, but there are some things, just a couple of things that that'll trip you up. The first one is anytime you've got a condition, and this can be an if else, but you'll also see on Tuesday when we go over looping, a looping conditional statement starts a block of code. And in order to do that, you put a colon at the end, and then when you hit enter in Notebook or in most IDEs, it'll automatically give you some white space at the beginning of the line. And Python depends on that. And it's kind of it's unlike a lot of other languages that it doesn't matter what line you put it on and how much white space there is before a line or anything like that. It's only there for readability, but for Python, it matters, and you'll get an error if you don't follow along with the way Python is expecting things. So the general format for an if else block, if condition, and that condition could be as simple as, you know, if A is greater than B, it will execute everything underneath that if statement. But it can be wickedly complex with multiple conditions in parentheses, and or you've already got the less than or equal to versus just less than. So you've got, you can, this condition can be really simple. It can be really complex. It's up to, you know, your problem solving. But you put the colon at the end, and I, you know, when I haven't been programming in Python in a while, I'll forget that and it'll error on me. And then you need white space before the first statement. Now that I'm talking through it, I don't know that there's a an exact amount of white space. I think it just can't be in the first column, but we'll test that when we get down into my next code block. And the else leg will execute unless this is true. And if it's true, these things will never execute, and it won't go to the trouble of evaluating the else, which can matter for performance. There will be times when you want to list things and check things in a specific order if performance is an issue, if you're doing anything very complex. So there you go. There's if else. So down here in this next code sample, I'll walk through it and then I'll execute it. We've got a variable we're calling income that we get from the user. Enter your gross income, and then we change it to int. So no error checking here, right? We didn't check to see if they entered a you know, not enough. If they enter a string or a floating point, it'll choke. But we've got two legs here, right? If income is less than or equal to 45,000, we print I'm in the income equal to or under 45,000 branch, and that is purely a diagnostic. That just lets you know when you're writing these if then else, and particularly, you know, if then else within a loop and whatnot, you know, nesting, getting complex. I use diagnostic statements all the time, and I don't think it's really intuitive because my son's in a computer science program, and I asked him, you know, he's just running it without any print statements within the algorithm and looking at the output, and one, you know, scratching his head as to why not it worked, you know. And I'm like, well, where's your, you know, you got to put some diagnostic statements in there. And in his education, he had not been taught that. And I think that goes back to because most of his education was in a full stack web boot camp. And that Java code out there on the internet isn't printing anything out to the console in an interactive fashion like we have here in this Jupyter Notebook scenario. So you can put diagnostics out there while you're writing the Java code, but when it goes in production, there are no print statements. It's just doing what it's doing and returning a value, and then your web page, your HTML, JavaScript, and CSS displays the result. So I don't think in his training they really did much of this. But yeah, when you are doing your exercises and trying to figure something out, putting a print statement in there to let you know what the heck is going on and what the value of the variable is as you crank, you know, as the computer cranks through the instructions, can be invaluable. So make sure you're using those whenever appropriate. So yeah, we test income. If it's less than 45,000, we will do these 3 lines of code. A print statement will assign 0.16 to tax rate, and we'll set tax bracket name to low. Otherwise, And again, this first if could have been really complex. Otherwise, else, colon, will do these 3 lines of code. So those are 2 choices. Either income is less than 45,000 or anything else. It's going to execute that. So if there is some other condition where you might not want to do that, you've got a more complex problem to solve. Okay. And then let's see. I got another thing I want to test. I think Python really likes this blank line, but it may not be needed, but I think it's good for readability. You'll notice here that I put a blank line before the if and after the else. So it stands out. I don't think you need those, but they're good for readability, and anything that makes the code readable is good, generally speaking. All right, so I'll run this the way it's written. So yeah, if I got $44,000, and again, if you put anything but an integer, it will explode. I am in the income equal to or under 45K branch. And there you go. And it calculates the tax. So it pops out of the else, sets that tax amount equal to tax rate times income. And, we set a higher tax rate for the higher income folks. And then here is a named parameter, or I'm sorry, a function within the print statement of format. So we're formatting tax amount, and then this is that format mask I told you about. And I am bad because I don't goof around with format too much. But if you Google Python print format tutorial, you'll get good information on that. Generally, it only matters for output. It doesn't do anything for calculating, or it has no impact on logic. And most of what I do is problem solving and whatnot. It's not really making things pretty. So I admit that I've been really bad about learning those exact format amounts. But there's a syntax to this mask that you send to format. You're sending it what you want to format, and then in the next parameter to the format function, you're sending a format mask, and that tells it how to, so this is in this case, it's 2 decimal points, because you are in the low tax bracket. And this space is extra, right? Should have got rid of that. Let's do that. Get rid of that. Rerun it. See how it's got 2 spaces after the? That bugs me. So you'd think if that bugged me, I'd learn more about formatting, but lazy. 35,000. You're in the low tax bracket. There you go. Okay, now a couple of things I wanted to check was really, do we need all of, I think it tabs it in, but what if I just put a space? Yeah, it's in red text. I don't think it's going to like that, but I want to reconfirm your gross income. Let's go the other leg now, 56,000. Yeah, it worked okay, but it changes the conditional formatting, which kind of weird. If you just hit return, yeah, if you or if you tab it in, that's what it is. It's inserting a tab. It goes back to the conditional formatting looks correct, even though it didn't seem to affect the execution. So interesting. But you know what? I didn't do that leg. So you guys should be stopping me. I didn't do that leg, did I? I did this leg. and Python is an interpreter. So it won't tell you when you've got an issue with something that doesn't execute. It tells you when you've got an issue when it gets to it. And in my example there, I didn't run it. So let's see if make sure. Let's make sure. And I will run this and do the high bracket again. Nope, seemed to work okay. It just screws up the formatting. So yeah, as long as you've got white space, at least one space, it'll work out okay. Tab. And the other thing I wanted to make sure, I don't think we have to have this white space after the else. Enter your gross income 60,000. Yeah, you don't have to have that white space after the else, but I think it makes for good readability. Whoop. And it's because it's after an else. Did you see how that was kind of goofing that up? When I hit enter, it automatically indents for me. If I come in here and if I had another thing that I wanted to do and I just hit enter, oh, I've got an extra space in here. That's what it's doing. If I just hit enter, it'll automatically indent it. So it's doing things for you. Like, you know, like I told you, inserting, you type a single quote. I'm going to do print. If I put in the left round bracket, bam, it automatically sticks in the right one, even though it's not smart enough to know when I don't need that. And you got to go back and get rid of it. If I put in a quote, it automatically sticks in the second quote. So just beware. You can't always just type away, or Python will stick something in there trying to be helpful that will screw you up. Okay, any questions on if else?
Oh,
Okay, you'll hear this referred to as if then else. In other programming languages, you would see the keyword then out there. If income is less than 45,000, then, because it's more English, more reading. So I know for sure in Pascal that use that syntax, but in Python, it's just that little colon. If income is less than 45,000, then do this stuff, else do this stuff. Otherwise, okay, so that's two conditions. And those, you know, they can seem like multiple conditions, and very quickly you can use and. If income is less than 45,000 and age is something, we'll see that here. All right, so that's two choices. And then this one is really two choices, but there's no else. Like maybe, for example, maybe you've got a report that you've written in Python and you want to do something, and it runs every day, and you want to do something weird every Tuesday or the first of the month. If it happens to be the first of the month and you're running this thing, you want to do something special, but there's no else. You're just going to do that something special based on an if condition. That's what this next one is. So you don't, and all that means is you don't need an else. You don't have to have an else. But for whatever reason within your logic flow, if you've got an if condition and there is no other whatever, you want to do something based on a condition, you just write the if block just like you normally would. Okay. And here's an example of that. And I put go back and fix the extra spaces around tax bracket name. Yeah, you are in the, you don't need this. I think I got ahead of myself doing this, enter income. So if we say it's 44,000, we're going to do the if, but there is no else. So if I say 55,000, it's going to keep the stuff that we put in at the front. It's going to keep so you set it for the default, and then you can do some if logic to change that. So this way, kind of as a programmer, you've kind of written the else as the default that will happen every time. So it all depends on what you're trying to do, how you structure these things. So 55,000 won't go in and set tax rate to the lower and set tax bracket name to low. It'll keep what we had assigned up here at the beginning of the program. Enter. So we're still in the high. Okay, now the third major type of conditional statement is multiple, more than two choices, 3 to 50, whatever. In other programming languages that you might have studied, this will be a case statement. In SQL, for example, we will use a case statement for multiple examples, kind of in a where clause. But in Python, we use elif. In Pascal, it was else if. Any of you guys C programmers? What's the C syntax for a multiple condition thing like this? C or Java? You guys, I know you guys have had some training. You guys still with me? My mic on?
No, yeah, we here. I don't know. I don't have any experience with either of those. Just Python.
Okay.
Like I get the if then else all that.
All right.
elif.
So I guess it's been a little while and
Yeah.
for everybody. Well, good. We'll kick the cobwebs off and I'm not wasting your time here. But yeah, in different programming languages, this structure will be formatted differently and you'll use different keywords. But in computer science in general, this is a pretty standard stuff. So in Python, yeah, if we've got condition 1, condition 2, condition 3, as many as you need, as many elifs as you need, and then you still have the else, the otherwise, and it always comes on the end, and it's your if all else happens condition that's what will be executed. And this very often we'll have some examples down here. It can be like a menu or whatever. Now, something to remember is that if the if is true, if condition 1 up here in our example is true, it will execute the statements underneath the if, and then it will end the entire code block. So that's another thing to keep in mind. You want to put like the most likely stuff up front so that it's not checking conditions for nothing. And you can also write code that is logical if you put the elifs in the right order. And the next code block will give you a good example of that. We're not at break yet, right? Didn't we come back at 9:20? Yeah, I'm going to finish this notebook regardless. and then turn you loose on that exercise. Okay, so there you go. If the if is resolved, condition is resolved to be true, bam, we come all the way out to after the else. And then we'll check, the elif condition 2. If that's true, same thing, bomb, out to the end of the block, the whole block. It doesn't check things just like you'd expect. It does not check things. So after something is true, after one of the conditions becomes true, it checks them in order. So that's important for you to keep in mind as you're solving these logic problems and telling the computer what to do. That's the way it operates, and that's the parameter within which you must operate as a problem solver. Okay, and here's an example in the next one. So we're going to put in a final numeric grade. And again, not doing any bounds checking. So if I do something stupid, like A, my final numeric grade is A. You can't do if then else numeric math on an A. So yeah, there's, you can put the logic in to error check all this, and we may work on some of that. But generally speaking, like I said, this is minimally effective Python. Beg your pardon, just a sec. Spam. So yeah, we'll put in an actual numeric grade here. And if I put in something that is greater than or equal to 90, so I'll say 91, it sets letter grade to A, and it doesn't ever check to see, like, if you put, if you had a logic error and the next condition was if it's greater than 100, it'll never see it because it met the first condition. So if I were to put in, like, for example, 101, the grade is A. So it met the if condition, set letter grade equal to A, and went all the way back out to this first blank line after the else. If for some reason I had put in a logic error as a programmer and I had if final grade is greater than 100 here, it'll never see that. So that's why these are in the order they are in: 90, 80, 70, 60. Because it will check them, and almost like it's going through gates or whatever, it'll check each one. And if it's false, it goes on to the next one. If it's false, it goes to the next one, and then the next one, and then the next one, looking for a true condition. And if it doesn't meet it, then you do the else. So we'll run a few examples here, like I think we can do a negative 20. You got an F. Can you get negative points? That'd be horrible. And it doesn't check an upper bound. And checking user input is something you would normally do repeatedly in a loop until the user entered something that you're expecting. And you would repeat until your data validation logic is true. But again, we'll do a little bit of that. I may add some this time. Your final numeric grade 1,000. There's still nothing better than an A. Any questions on how that block works, how that block operates? Just need some hands on. See if you got it locked in.
I had kind of a question.
I get it.
Cameron, was that you that had a question, or Edgar?
That was
Oh
it,
no, I said yeah, I get it.
me.
Go ahead, Edgar.
So I was trying to do some validation kind of for if they entered like a instead of a number.
Mhm.
How would you do that? I did like if input equals to type string, then print enter grade in numeric format. And then I guess you'd have to put a loop to restart the input.
Yeah, normally, and I think when we get to looping, I think I got an example of that. And if I don't, I'll certainly cover it. But normally what you would do is you would say while the input value, you'd have it outside the loop before you get to it, you'd have your input statement. And then you would do a while loop, checking to see if it's right. If they did it right the first time, the while condition would be false and it wouldn't do it. Otherwise, it would fall into that loop. And the way it depends on what you're looking for them to put in. If it's bounds checking, your condition would be, if you want them to enter something between 5 and 10, your while condition would be checking those bounds. If it's just the right data type, you could just say, I think it's is numeric. I'd have to look real quick, but you can check what's in a variable by calling a function. But I think I want to get to that when we get to looping.
Okay, yeah.
But that's what you do is you'd loop until they put in what you're expecting. And so so there's like a priming, and then inside the loop, you keep asking them for the correct input. Okay, so here we've put just one level of logic, but you can nest an if elif else block inside of any other block of logic, and it does the same thing. It doesn't, and you can nest them. I've never run into a limit, so we'll cover that. So this is where you have multiple conditions, and depending on your coding style and the logic, this is kind of like saying, in this next block, we're gonna get cholesterol from the user and their age. So now you have a combination of cholesterol value and age, and you want to do different things based on, if their age is one thing and their cholesterol is another, we're going to do one thing. Otherwise, we're going to do something else. If it's the other combination, there is an and operator in Python that we've got examples of in subsequent lessons. But so for this one, just want to show you, if I enter a cholesterol of less than 120, which is good, and I enter an age greater than or equal to 65, so an older person with good cholesterol, we set their category to low and Medicare eligible. Medicare eligible is anybody 65 or over. But inside of this if block, so low cholesterol, but they're not Medicare eligible, we say cholesterol category equals low, Medicare ineligible. So the else leg is checking, it's not looking at age at all yet. It's only checking cholesterol level. So if they've got high cholesterol, then we run down into this this block, and now we say the same condition. But since we are in the high cholesterol leg of the outer if else, we say that cholesterol is high and Medicare eligible because we're in the age is greater than 65 leg inside in the inner if else. And then else, yeah. So you got it, you're young and you have high cholesterol. So cholesterol category is imminent death, high Medicare ineligible. And you can nest. It depends on how you want to. Let me see. Let me see. I got a note to myself here. Example: nested ifs. Note there will possibly be an error message until you fix the logic. So I made a note to myself 6 months ago. Well, let's run it and see what I get. I have no idea why I put that. There you go. Another example of why meaningful comments are so important, because I do not remember writing that and I had no idea what I was talking about. So I should have put a better comment in there to myself. So let's run this and enter. I'm trying to think of why it would, because we're inting something. So of course, when I enter my cholesterol, I can't put 121.1 or it'll, of course, I know it'll bomb. It's not error proofing it. I don't know. Let's say, let's do a low cholesterol first. And we'll check each of these combinations. And we'll do low cholesterol and high age. Low cholesterol, high age. Okay, so that worked. So let's do low cholesterol and younger. So that worked. So now let's do high cholesterol and young. So high and young. High and young. And let's do high and old. 35 and old. My mama is 88. That's old. So that works. I'm going to take that out because I don't know what I was thinking of. Yeah, I don't know. I must have fixed it. Whatever that logic was. So that's how you nest conditions. But like I said, there is an and condition. You can say if LDL cholesterol is less than or equal to 120, and age is greater than 65. So you can kind of combine things, but there are times when you don't want to combine multiple conditions into the same condition, because that and makes it just one large compound complex condition that gets resolved to either true or false. So it kind of depends on what you're doing and how you want to approach this. And there may be better ways to do it and to make it more elegant, less lines of code, less decisions and whatnot. And that's what code walkthroughs are good for in a no kidding production setting, where you got to make sure you've got thick skin, because all your coworkers will say, you could have saved a line of code there by doing something different. But that's how you nest these. And then, like I said, this nested code block can be another complex if else, and within that you can have another if else. I mean, they can be as complex as necessary, and they may not even have anything to do with each other. You know what I mean? The branches of this logic and the way you're nesting, it could be that those things have little to do with each other, but yet Python will evaluate them and do the right thing. Any question on nesting? You see how we've got to have you still have another colon. Each block still has to, each level of nesting still has to have a colon. And Jupyter Notebook will automatically tab it in there. See, I just hit enter and it knows within that block of code, I want to start on this line. You start goofing around with that and you get weird results. So you want to stick with the level of indentation. All right, easy enough. Here's another example. Yeah, and a not. I'm stealing my own thunder. This is a typical example. It will, you know, you can give your user a menu. These are in these little console applications. You could give your user a menu, and they enter their choice, and you check for one. It will print English and bomb out. It won't check anything else. If they put in 2, Spanish. If they put in 3, French. Otherwise, it doesn't matter anything else. And you see how we got it in quotes here, because why is that 1 in quotes? And not a numeral 1 like we had up here?
We didn't convert it to an integer.
We did not convert it to an integer, and input defaults to returning a string. No matter what you put in, it always returns a string data type. So it doesn't know that is a numeral 1. It just knows it's a character. So there you go. You always got to do conversions. And you'll see that, guys, in Python. You're constantly managing data types and this whole dynamic typing environment. Okay, so there's another if else block example. Oh yeah, not getting what data type does input return? That's easy to forget. I mean, there's just so many ways to screw it up. So logical operators, and, or, and not. So like I said, we could, you can put and between conditions up here, like if cholesterol is less than 120, and age is greater than 65, you could do this leg. You don't have to do it as a nested if then else, because you've got the and or condition operators. So you just got to get it right as a programmer. The or is just like in English. If A is less than 1 or B is greater than 3, if either one of those are correct, then the statement is true, or the condition will be resolved to true. So yeah, just beware as a programmer. And we've got an example of and or logic in the next code. And a less than or equal to operator is kind of an or operator. You got to remember that when you're working with it. So here we're going to input final grade and set, or I'm sorry, their final numeric. And then we are going to set their final grade. And then we're going to set another variable. So now we got 2 variables to evaluate in our conditions. So down here, inside of parentheses, we've got a condition. If income is less than or equal to 45,000. And, oh, here's an interesting method call. I'm going to have to slow down and introduce this one. So if income is less than or equal to 45,000 and the letter grade from the previous chunk of code dot upper. So if the upcase of it equals capital A, then we're going to do this print statement here. You're getting a big bonus because you make less than 45,000 and you did really well in the course. Okay, so let me slow down here and talk about this portion of the code. Letter grade, remember from previously, letter grade is an object, a string from the string. It's an object from the string class. So it has been created, and it will have behaviors and attributes that are specific to strings in Python. One of the behaviors, which is called a method, is to return the regardless of whether it's uppercase alphanumeric or not, or alphabetic or not, it will upcase all of the dot upper will return the capital letter of any alphabetic character in that string. So it can be a little confusing and a little frustrating, because sometimes, as Python evolved in this, this open source community nature, sometimes you would call a function, and there may be a function called upper that you would send letter grade to, kind of like the print function. You would say upper open paren letter underscore grade, and that function call would return any character in that string, their capital letter. So sometimes there's a function call that does what you want to do, and there's a method that's part of that class that does what you want to do. And using them is really just a matter of personal preference and what works best for you. But in this case, we use a string, a method of the string class called upper to change, even regardless of what we put up here. We change it to capital. So we don't need to do it. We set it equal to capital up here. So I think I just did that as an example. But it's good that I'm introducing that every once in a while. So if, like up here, let me change that to lowercase a. It's still going to be true when we get down to this here. But back to if elif, and the and or. So if income is less than 45,000, so the same, this condition here, we're repeating that condition, but now we're adding an or of a final grade score is greater than 80. So your lower income, or you got better than an 80%. And remember, this had to have been false for this elif to execute. So if income's less than 45, or they're making greater than, regardless of their income, they're making greater than an 80 in the course, we print you're getting a gift card. Otherwise, elif not, and that's the other not logic, is just here's an example of it. It's useful sometimes, but it can twist you into knots. Otherwise, if they didn't get an A, we say thanks for taking regardless of their income, thanks for taking our class. But as you can see through, as you go through these, some conditions can no longer be true, like a higher income person would never get down to these other ones, these other legs. So it's all in how you write it, all in how you construct it. And then I think we covered we covered every condition here. So I don't think you can ever get to the else, but if you can think of a condition that gets to the else, let me know, because I think I covered them all. So final numeric grade, I want to give them a 91 so that it gives them a lowercase letter A. And I want to give them a low income because I want to check that first if down there. So enter your gross income amount, 44,000. You're getting a big bonus. Yeah, this upper, actually, let me put in a new code cell and see what is in. I know I'm not printing like I usually do, but yeah, it's a lowercase a. So this upper method call temporarily, or it returns, it doesn't reassign the value. You would have to actually do an assignment statement and say that letter grade equals letter grade dot upper in order to convert it from a lowercase a to an uppercase to a capital A. Here it just returns it for the sake of evaluation. Okay, and then the next leg, we don't need that. That'll just confuse me next time if I leave that code block there. So what's the next logic? Let me go ahead and get rid of, put it back where I had it. We don't need that. Why? I had to have put that in for a reason, but it bugs me that I go off script, guys, and I start modifying my code, and then it doesn't necessarily make sense to me next time. I'm sorry. So enter your final numeric grade. Let's give them a less than an 80%. Yeah, let's give them a 79. And shouldn't matter because they didn't get an A. Should do the thanks for taking our class, no matter what I put for income. I'm looking. Thanks for taking our class. Let's run that again and do something under 45,000. 79 and 44,000 this time. Because income was less than, yep, because income was less than 45,000. It did this leg. So it all depends. And again, once, no matter how complex and convoluted that condition is, if it's true, it'll do this part and it won't do anything else. And then the next one, if this is true, and sometimes you can do something convoluted that doesn't really make any sense. There's nothing to keep you from putting in a logic error. But if this leg is true, or if this condition is true, regardless of how complex it is, it'll do this next line, and then it won't do anything else. So there you go. Any questions on and or not? This reverses this condition, just like you'd think. Okay, they are tools in the language toolbox to be used at the programmer's discretion. And you can, I've seen some pretty hairy code that was way more complex than it needed to be. And I'm sure, written code that was way more complex than it needed to be. But that's the syntax of the language. Those are the tools in the toolbox for you guys to use. Okay, a Boolean variable is a data type that you use a keyword to set it to, so it automatically when you use this keyword false or true, it automatically sets it as a Boolean. And now, if you name that Boolean variable appropriately, it makes sense linguistically when you're writing your code. So if you can say, like here we can say here, if past class, and then the logic that past class in that if is a condition. It's a variable that will be resolved, just like when we did the print statements above, and it printed the resolution of that past class variable is a condition. And like I said, if you name it appropriately, it reads elegantly in your code. So by default, we're setting past class equal to false, and we're printing it out just to see what we got there. If they enter anything greater than 59, we change the default value to true. Print it out again just to make sure. And then if past class, print you passed. And that's just an example of a Boolean variable, Boolean data type. So we'll give them a 67. It's false at first because that's what we set it to as a default value, but then we did some logic and set it equal to true. And there's no need to do this. If you're looking at this and go, why the heck would you do that? You're right. It's just an example, because you would say, all you need, you'd print you pass if it's greater than 59. But there are times when setting this stuff makes sense. So there's your syntax. There's the tool for your toolkit. Okay. And here's another one. Another coding example. And then another down here with all with if, elif, else. Now, this is not your assignment, but if you guys are aspiring to be Python programmers, this is an interesting exercise. Typical flowchart, conventional flowchart notation. You get to a logic test here, an if test. You've got your true leg and your false leg, and then another income and true and false. Then they rejoin, and end. So this is standard flowchart. If you would like, you can code this up. Give it a shot or two. If you can't get it to work, let me know. I'd be happy to make suggestions. Any questions on what I've covered?
No questions.
Okay. Yeah. And again, Edgar, we'll do a little more with data validation and a loop, waiting for the user to put something. It's in Notebook 4. You're welcome to download it and preview that if you want. So let me go to Python exercises 1. I've got a 3 next to it because I've downloaded it 3 times. But here's the exercise. It's from super easy to challenging. If you're experienced programmers, it won't slow you down too much. But if you guys could use the next 2 hours to work on this, if you get done early, groovy. Like I said, there's that brain teaser at the bottom of Notebook 3. That's really good practice, really good turning what a business analyst would write up as far as logic flow, and converting that into an executable Python program. That's a really good mental exercise. So I think you've got plenty of syntactical examples here in Notebook 3. Again, when I'm coding, I rarely start with a blank code cell from scratch, without an example of what I'm doing. Rarely, when I'm really working on a Python if I'm in the middle of a project, helping somebody out or doing something for myself, and I'm getting really, refamiliarizing myself fluency with the syntax, it's okay. But generally, it's, there's no shame in cutting and pasting this code, if you think it's useful, and then kind of modifying it to fit the problem that you're working on. No shame in that at all. So if you guys would, here's the notebook. It's in with 5 problems. Python exercises 1. Yeah, I've got the instructions in a markdown cell here. I'll hit Control Enter and execute that markdown. And then I went ahead and put in a code cell. Looks like I've executed this once. So you've got the code cell already to write your solution in there. So yeah, put your solution in the code cell. Make sure you do a save and checkpoint, and then file, close, and halt, and then just upload your version of this to the assignment, the IPYNB file. And if you would, put we don't have any repeated first names. Just put your first name at the beginning, because from Canvas, I'll download these into my downloads. And if everybody uses the same name, they look the same in my downloads, and I can't remember whose is whose. It couldn't hurt to put your name in here too. I should have done that in the first markdown cell. You double click on that and just put your name so I can see it real easily. But it'll be in the file name. And I'll try and remember that for next time, to put your name on your work. Any questions on the assignment? If you get stuck, I would ask you to email me what you've written. And if I'm not on my computer and I see it on my phone, I might be able to reply without having to be in my office. We good?
Good.
All
Yes,
good.
sir.
All good. Okay. If you would turn in something, you don't have to get it complete if one of them's messing with you. But turn this in by the end of class today, 12:30. So I know you're good to go. And again, if you're having trouble, shoot me your code via email, because I'm not going to sit here with my headphones on the Zoom session. You're welcome to exit the Zoom session, and we'll go asynchronous, and upload that to, where's that assignment? Python programming. Bam, underneath notebook 3, Python exercises 1. All right, cool. We'll see you guys Tuesday morning. Holler if you need me.
See ya.
Yeah, have a good one.
Thank you.